Aloha. Thank you for attending my lecture, Beyond the Big Bang, Advanced Yondtian Cosmology, in my Novel Theories lecture series. I am Garrett Ford. The topics covered during this lecture are the review, where we'll be briefly reviewing some of the core concepts that, if you've missed my other lecture, are fundamental in understanding what we'll be going through. Though I do recommend not going into this lecture blind and to rewatch the elementary Yondtian Cosmology video. Next is the explanation of mote, pole, spiral, frequency, and qubit. That is the fundamental parts of Theotokian universe. And then the emanations model, which is quite different than our current Big Bang model. And then lastly, where does this all go and what does this maybe help us do, which is all about interaxial broadcasting and alignment. The review. With the Euclidean universe, lines are straight, well, as straight I guess as I can draw them, and they are contained within nested series of singularities. You have matter existing in 3 dimensions. However, all of them are nested within a singularity of time. And that singularity of time exists as a line, and then a plane, and then a cube, and onward, and onward, and onward. Turtles all the way up and all the way down until they reach the lowest singularity, the fundamental singularity, so to speak. Now, we'll be going through that a bit more, and that would be what we would look at maybe as a black hole, is perhaps that fundamental singularity at the bottom of it. And we also covered what was a white ball, which is the opposite of the black hole, where the black hole is a singularity that constantly is sucking in everything around it. The white ball is a plurality that is constantly exuding in all directions from itself. And while this has a event horizon, this would have a Beweisbar limit. The Beweisbar limit is the absolute limit at the edge of a white ball that cannot be crossed, in the same way that at the event horizon cannot be escaped. And so that is just your the review of those two concepts. Now, within the if anyone has seen the other ones, the other lecture, and I do hope that you have, you would understand the kind of repeating and repeating on and on with the Euclidean model of the straight lines nested within each other. And of course, this model that we'll be explaining today in the advanced is at that bottom 0 that I pointed out in the first lecture and explained that yes, well, we will be going over the advanced stuff here. This is the opposite side, so it gets a bit different. Another piece to understand is that the universe is divided into 2 halves. You have the let's say a upper half, where perhaps, let's say, if we were looking at the universe as a globe, you would have, let's say, here, I am in Saskatoon, Saskatchewan, and somebody down here, let's say in Watanabe, Australia. To me, observing them, everything works in the opposite. Everything does not make sense. They have black holes that are spitting out stuff that would be more operating like white bulbs, and for them to observe us, they'd be like, oh, geez, they've got all these white bulbs that are operating strange and sucking everything in. So that's one of the first things is you have the dimensional equator, which is when everything reverses. It's that line that goes across the kind of the universe like a barrier, but not a barrier of sorts. And yeah, we'll be discussing that a bit further in another lecture. But anyways, that's just your review of some of the core concepts that you should understand. Now, unlike the previous slide where I showed the nested repeating Euclidean universe, this one is the Theotokian, which of course starts with a mote. That means there is no singularity to start at. You actually will always be starting at 1. In the same way that perhaps a number series like the Fibonacci sequence starts, or the golden ratio, perhaps. I use those two because this is a largely unplumbed area of theoretical physics, and we are looking for the constants in this universe by using the signs that are present in nature and mathematics. So it might be some time before we actually uncover some of the constants that I'll be just using placeholder numbers for in this lecture. So first you have your mote. Now your mote is the sphere that you are measuring from on top of. So in this case, it is Earth 52. Now it's Earth 52 because we have 52 perfect numbers, and one of the best ways to distinguish one-dimensional area from another or one observational axial from a number is the use of mathematics. So your mote, that is Earth 52, which is, of course, atop the white bowl rather than the singularity for the Euclidean, where you go to 0. So that is at the center. Next is your pole. Now, I use the pole because it is showing the difference of direction between the termination point and the emanation point. Now, depending on which way you want to go, you could have maybe your emanation point at your south pole and your termination point at the north pole, or vice versa. Doesn't really matter. Time is not an arrow, but a ping pong game. Forwards or backwards, it's all the same. Next, you look, so the pole, of course, we're going to use the 23.5, which is the direction of the pole on this planet. And then next you have the spiral, which would be your around this, going outwards, expanding out and on. That is your spiral. And that would be perhaps, let's say, a number that appears in nature a lot, that 1.61 repeating and off and on. That would be your golden ratio. And so this is the effects of the Theotokian universe acting upon matter. And so this is like the bend that you see in everything because of that. Though it's invisible because of the scope that you are observing from, you have that is perhaps the spiral's curve. Now the spiral, you can divide it up into cuvits. And so the cuvit is everything contained within the three-dimensional matter, along with the your singularity of time on top of it. Now, the thing is, these are not contradictory theories. These are buttressing theories that complement each other, which is why they do use each other. And so what you have is each qubit on and on, getting bigger and bigger, out and outward, just like your Fibonacci sequence or golden ratio does as it goes further and further out. Now each qubit, like I said, is your x, y, z, and the t, but it is going to be curved, your tet rather, that contains it all. These are all contained within the qubit. And so just as the bottom of the singularity houses all the different you have your plane, your line, plane, cube, etc. In the Theotokian universe, you're housing everything from above below, and in the Euclidean universe, you house everything below above. As above, so below. And then you have everything contained within your qubit. Let's say if we're going to use that one to observe, is your frequency. And so that is the vibration of all the matter, the movement of time, the direction, all that stuff. Everything, all of it is condensed in frequency. So we would use, because let's just imagine it's broadcasting from everyone's favorite radio station. Let's say it's broadcasting at 4625 kilohertz, just for an example number. And again, as we become more familiar with this novel theory of physics, we'll actually fill these in with half-decent numbers. These are just your placeholders. And so that is the frequency. And so everything contained in there is vibrating. And what you can do is observe that vibration as right now, let's say you are at the middle of this. You are observing outwards. That is the cone of your observation. Each moment, let's say that's moment 1, moment 2. We're thinking about 3 seconds ago when I showed you that, moment 3. You're observing here, and each one adds to all the previous moments you've observed in the kind of spiraling astral coral, as it would be called, that you occupy, growing from your emanation point, up and away, to your termination point. And so your emanation point is the place where you and everything that you know and see was emanated from the white ball, hence the name emanation. And so there is, under this model, which we'll go in later, there's no Big Bang. It's just a series of emanations from a white ball that spiral outwards from it. And that's the fundamentals of Theotokian universe. So the emanations model is quite different than the current model about a Big Bang, where there is an event and then there is nothing before that, and then it all comes from that moment. Now the emanations model is that it is just a constant circular emanation after emanation, creation after creation, and collapse. You have your emanation from white ball, you have the collapse into a singularity, and then from that singularity, another white ball, and on and ever and ever. And it's not going to be a cyclic universe and purely deterministic. In all likelihood, it's going to be a spiral, and just an ever repeating spiral and cycle. And so that it flies in the face of a lot of the Big Bang was the start of everything. No, there is no start, there is no beginning. We are talking about eternal systems that are fundamentally paradoxical, and with the emanations model, paradoxes are not contradictory, but they buttress and they support. And that is what makes the system strong, is that you have all these different parts of the emanation. Even though they seem contradictory, they're actually working towards the same creation, as in the same way that, people will say, oh, that's not connected on Earth. It's like, well, actually everything on Earth is technically connected, because everything on Earth is on the same planet, and therefore, there is a particle of your ham sandwich that is touching a particle that is touching a particle that is touching a particle that is touching me. So go easy on eating all the ham. Get it? No, it's not very good. Large ham, Hamlet. Never mind. Anyways, that's my attempt at humor. To be or not to be. Lectures are a lot harder when you don't have an audience. Anyways, so back to the Beyond the Big Bang. So it's an eternal system, and our own, there's a heat death and a beginning and an end to the universe. That is mostly us projecting our own anxieties about death onto these eternal systems, which is why they are categorically rejected within the emanations model. It is just emanation after emanation. There is no beginning. There is no end. That's the definition of eternal. And, it's that infinite spiral, or that Mobius strip, whatever you want to call it. And maybe even not a cycle like that, but instead, like I drew, the spiral. So that's one of the biggest things that turns a lot of the other theories that are out there on the head, is that we reject the idea of the Big Bang, because it's again making that assumption that the universe functions the same as what's essentially a cosmic worm crawling blindly through time backwards. Now, next you have orthogonal versus linear time. Now, the previous slide, we drew that, and now this one, we have your, you have, let's say, your emanation point, and you've got previous, you've got a previous termination point there. Now your emanation goes out like this as you observe more and more possible things. And just like, when somebody's a baby, nobody knows what they're going to be. Maybe they're going to be a painter. Maybe they're going to be an astronaut. Maybe they're going to be a YouTube personality that writes weird science fiction that doesn't seem to sell. And it collapses once you reach a certain point until you reach your termination point. Now, that's kind of just now that's the whole range of all the things you could be possibly is contained within that kind of elbow angle. However, you are only observing this line or that line at a time. So, you have 3 paths. One of them, pirate, philosopher, zookeeper. Who knows what other lives I could be possibly living, but this is the one that we're on right now, the YouTube theorist who's trying to get their science fiction novels to sell. Now, moving along that line, from the outside now, that's linear time. That is your linear time. As you move through the emanation, you're observing it as linearly. Now, if you had a way to get outside and above, let's say, orthogonal time, that would be, let's say, viewing it from this outside angle that lets you see all possibilities, all paths, almost like the, let's say, the eye of God, you know, from the, what was the, Ra, the eye of Ra from the $1 bill. Yeah, kind of like that. It's able to see all the different paths you could take. So you go that way, left or right. Okay, we keep going left. Okay, now we're going right. Okay, now we're going this way. So it can see all the different paths that you could possibly take within that. And so that is your orthogonal versus linear time, which is very important for understanding this, because it also accounts for the whole free will problem, where it's like, well, if everything is contained within that, it's like, no, you still can choose where you're going to go, but there's only a certain possible amount of ways that you could go because of the limits placed upon you by the amount of time you have from emanation point to termination point. In the same way that, you're not going to live for 100 billion years, so there's certain things you could never achieve, such as, building a skyscraper out of iron atoms that are piled one point upon another, one by one. You're just not going to be able to do that in the time that you have. And so that's the orthogonal piece of this. And you are experiencing time linearly. An event happens, and then that event has a cause. You perform an action, and the action causes an event, and that's your causality. I got that mixed up there. So you have an action causes an event. Now again, since time is not a arrow but a ping pong game, it goes backwards and forwards all the same. It can also go backwards. It could be your event precedes the action. So I've used this example before. You receive a nice Christmas sweater from your aunt, and you get a picture taken in it. Because a picture of you wearing the sweater exists in the future, you need to receive the sweater in the past. And so it effectively locks you into that chain of causality. Now, where were we? Yes, orthogonal versus linear, beyond the Big Bang. Now, I'm sure that you have a lot of questions, so please leave your questions in the space below. And next, we will go into what do we use this all for? Interaxial broadcasting alignment is perhaps the first application of some of the things that I've been discussing today. First is you cannot stop that signal. So that's why it's important to look at frequency broadcasting and how to align frequencies. So this probably doesn't make much sense, but I'll give you some examples to explain it. So first off is between dimensions, how do you broadcast from one to another? Well, first you're going to identify your period. So we are in the Unix 32 era. And we are broadcasting from Earth 52 because we have 52 perfect numbers. Now, other dimensions, axials of observation, whatever you're going to want to call them, if we can start standardizing our broadcast to say, hey, I'm on Unix 32, Earth 52, these are the perfect numbers I have, and you can list your perfect numbers. That allows another dimension that might be receiving your transmission to go, oh, actually they've got a different perfect number that I don't have. So I guess that is a unique and distinct axial of observation. And so that's one of the biggest things is, can we communicate between these axials? So that's the idea with the interaxial broadcasting. So first, Unix 32, Earth 52, you can put your date. So today is July 23rd, 2025, and it's about, I don't even have a clock in front of me. What time is it? It doesn't matter. Let's just say it's 7. No, it's, well, there's a clock. There we go. 8:15 a.m. So that is all that. That is your kind of your signal header. And then of course you can put your location. So, well, you've probably guessed I'm not actually in Saskatoon, Saskatchewan. But we're going to put it there because it's such a fun a fun name to say and use. Saskatoon, Saskatchewan. Saskatchewan, Canada. All right. Now, if anybody receives your broadcast, they can go, okay, they're in the Unix 32 era. They have 52 perfect numbers. That's the date. That's the location on their map. And you could even include your GPS coordinates. And it's essentially like saying, hey, we're over here and this is what's going on. Now, that is just broadcasting. Now, the thing is, where you're just you're screaming into the dark, and it's being broadcast by your repeater. And I think maybe using a quantum computer could be interesting for that, like entering this data into your quantum computer, because they found that they're having difficulty clearing the buffer. And so if you put this into your quantum computer, somebody else that tries to use that computer that's maybe in a different axial of observation would maybe receive all this data. So that would be very interesting. I think that'd be very interesting to do. So, hey, NASA, hit me up. I need a job. I'm on the make. Business is super slow, obviously. I'm recording this at 8 in the morning. And anyways, yeah, I'm not going to complain. Now, so you're broadcasting in that sort of fashion. Now, the next piece is you broadcast this. Somebody maybe receives it. Well, now what? Well, they could maybe try to send a message back. They could say, well, I'm in Unix 32 era, but we have 53 numbers. Or maybe there's ones that have even less than us. They're like, oh, we only have 51 perfect numbers. Thanks for the extra perfect number. And then that maybe would help align them to your alignment. So it would be, helping you kind of bring everybody closer together, align the axials. And then you have the crossroads. So this is about alignment. This is how you might actually be able to travel between axials. So right now, what you're looking at through your screen, I could try and draw all this, but I'm not. So you're looking at a screen that is likely like this, and you've got your line of text there, a bunch of doodles, and maybe you got your like a drink beside you, your Hello Kitty mug. Meow. There's a kitty. Hello Kitty. And then over here, you've got your second monitor, and you've got like some other YouTube video playing, or whatever, and it's like Trigun or Cowboy Bebop or something. Who knows? Whatever it is on there. And you got your keyboard there, and it's kind of glowy. So now everything that you're observing there in that cone could be represented with a form of mathematics that I'll be going into very soon. I haven't even devised a name for it. It's so new, but it's quite cool. But everything that you're observing here can be reduced into a bunch of a vibrational frequency. That is your qubit, of course. So everything around you is in the cuvit, but everything you're observing would maybe allow us to align it, right? And so you are there observing all that. And is there a way for us to maybe have someone in another axial observe the same stuff in the same frequency and do an old switcheroo? So that's your crossroads. So yeah, that's kind of the idea behind interaxial alignments. So you create the same vibrational frequencies, the same vibrational circumstances as what would be present in the dimension you're trying to cross over to, and perhaps there's through maybe awareness or psychedelics or meditations or certain, I think it might have to do with perhaps, you know, those chants like the Om chant vibrating at a certain frequency, not only spiritually but emotionally, and perhaps that is part of it. But I don't know, because obviously I really wouldn't be slumming it in this dimension if I had a choice. So yeah, it'd be yeah, that's that. Anyways, that's the crossroads. And lastly, there is maybe a slight hazard, which is the static. And this is just a theoretical thing, and it's like a question of, okay, so you've got all these different axials, and now is there perhaps a like within the static, you know how, I don't know if any of you played around a bit with AI, but like when you're having it develop, like the image develop, a lot of times it's like all this static is coming into focus and being kind of parsed down to a image, right? So you have this big static image, and then it becomes a house and a tree and a person, right? But until that happens, it's a bunch of static because it's searching all these images and kind of constructing some kind of the picture you wanted to see, which is a house, a tree, and a person, right? So, oh, there's, hey, get it? Anyways, it's funny. So one of the issues is maybe the static. So you could maybe accidentally vibrate at a frequency where maybe something or someone from another outside outer sphere is able to cross over. So I'm not sure if that would be a hazard or what, but that's just a foreseeable possible hazard, and there is no reason to hold up any research in this based off such a silly notion. Anyways, so yes, that is the lecture for today. We went over a variety of things, and I hope that you've enjoyed them. And by all means, leave your questions and comments in the box below. Be seeing you.